Let's start with a graph of functions, and the typical point on the graph. F of x controls the height of the point. So if I add a number to it, like +3, then you raise the point 3 units higher. If I do this to the entire graph, then it raise the entire graph 3 units higher. If I subtract 3, then I lower the graph 3 units higher. So for the graph of f of x plus c, so if plus a number, we raise it. If subtract a number, we lower it. Here is x squared raised by 5. Here's x squared lower by 5 by subtracting 5. And the same thing happens when I multiply the formula by a constant. So if I multiply by 3, I stretch it 3 times its height. And so if I do this to the entire graph, that's what I get, a stretch 3 times its height. And at the point of roots, the black points here, they don't move because 3 times 0 is 0. And if I multiply by 1/3, I squash it to the 1/3 of its original size. And here are a couple of graphs, and here's 4 minus x squared gets stretched 3 times as high, and here's 4 minus x squared squashed to the halfway of its height. And what happens when I multiply negative numbers to the y component, and I flip it across the x-axis. So if I do this to every point, I get an entire graph flip over. And so if I multiply this by a constant, I will stretch. That's what happened when I multiply by a negative constant. And so it's a flip and stretch. And here is the part which is a little more confusing. The x plus 1 does not mean I move the graph 1 unit to the right. Here's what it means. To graph g of x equal to f of x plus 1, is at the point x, I go to x plus 1 and look at what f value is and bring that back over to x. That's what the value for g is. If I do this to the point u, I do the same thing and go to u plus 1 and move it back to the point u. That's g of u. If I do this to every point, I move the curve to the left for x plus 1. Okay, then it's x minus 1, I move it to the right. So here is the conclusions. So for instance, x squared, x plus 2 squared is moved to the left, x minus 2 squared is moved to the right. And similarly, this is for compressions and stretchings. The graph for f of 2x means at the point x, you go to 2x, and you find out what f is, and then you bring that point back, and that's what f of 2x value is. If you do this to every point, you will compress the graph by factor of a half. If I divide by 2 of a half x, then I stretch the curve. Okay, and that's stretch and compress.